we going? Can we see that?
Yes, awesome. We can.
Awesome. Okay. So yeah, it's a tough act to follow. Thanks for that, Andy. So yeah, today I'm going to talk a little bit about Splunk Heck, the HTTP event collector. So if you haven't had a chance to play around with Heck before, then hopefully this will get you started to play with a really cool feature that Splunk provides. So I always love a good presentation theme. I wanted to do Street Fighter because I love the whole video game aesthetic, and Street Fighter is a favorite of mine. Didn't plan it in that way, but our friends at Capcom had a bit of an incident last month, so it turns out there was a tie back to cyber after all. So yeah, I'll claim that one. We're going to be talking about how we've been using Heck to help automate the collection of threat intelligence for our cyber team at Athena. All right. So obligatory about me slide. So I'm head of cybersecurity at Athena Home Loans. So we're a fintech scale up in the home loan space. I've had about 10 or so more years in security. So I've been doing this for a while and been using Splunk for longer than that. So a bit of a Splunk fanboy. It's great to be able to talk about this stuff here today. All right, so I thought maybe we'll start off with just sort of setting the scene, understanding what problem we're trying to solve, and just make sure that we're talking the same language in terms of terminology and the words that we're going to use throughout the presentation today. So let's start off with the problem. So basically, any good or any cybersecurity program really is aiming to protect the organization from cyber threats. And really this is around the organization's data and also the reputation of the organization. So key to succeeding in that goal is being as proactive as you can be with your defenses and moving from having to react when you've had things popped to being more proactive and putting in decent controls to stop attacks from occurring before they occur. So one of the ways of doing this is to really prioritize your limited cycles, and I think Andy was talking about that in the last presentation, is that the cyber teams are really busy and you can only do so much. So really being able to prioritize what's most relevant to your organization at any particular point in time is really key to that success. So how do we know which threats are the most relevant? So really the answer is threat intelligence. So what is threat intelligence? So threat intelligence is really just data that you collect to understand threats that may be targeting you and what and how and when those attacks may occur. And having this information allows us to make better, more data-led decisions so that we can be as proactive as we can in defending against those threats. I really like this, this definition that was actually from the CrowdStrike site. So where can we get this data from? So there's a bunch of different places you can get threat intel from. But basically at a high level, firstly, there's open source sources. So basically the general internet. So looking at public sources like Twitter, the internet, all of the things that are kind of publicly out there and available for consumption. You've also got in-house feeds, so the stuff that you develop yourself within your organization. There are communities out there that are focused on this sort of thing, generally organized by industry. So you've got financial service ISAC, so information sharing communities, and there's critical infrastructure, a bunch of different ones out there, sharing information about threats that may be targeting, in particular, those verticals. As is the case with everything, really, there's always a pay option. There's commercial services you can buy that will feed you with this information in a customized or not so customized way, depending on what you've purchased. And there's also the dark web, which I differentiate from your open internet sources. These are the things that aren't really so much out there. And really what we're looking at here is probably primarily criminal marketplaces, things that are in the dark web, which give you an insight into who's being attacked, who has been attacked, and whose data is being sold on the dark web for nefarious purposes, and that sort of thing. Give you a really good idea about tools and techniques as well, which is important for intel. So more specifically at Athena, so as I said, I'm head of cyber for Athena, and we're a reasonably young organisation, and so is our cyber team. So our cyber team was born earlier this year. So we've actually only been in existence at Athena for sort of 10, 11 months or so. So as is the case with organizations like us starting out with sourcing intel, really we're focused on the public domain and the community. So in order to get the intel that we need to do our job effectively, the first thing we did was we started off by partnering up with the Australian Cybersecurity Centre, JCSC. And for those of you that haven't done that, that's a really awesome thing to go and do. Hooks you into a bunch of like-minded people throughout the Australian community, sharing this sort of data in a safe way, allow everyone to benefit together. But it's also about maintaining strong personal networks with other people in the community and sharing freely both ways with those networks. As I said at the start, been doing this for a while, so I'm lucky enough to have a reasonable sized personal network that is open to sharing this sort of data. And obviously we share back into that community as well. So that's really awesome. We also monitor various public sources to get information about attacks that may be targeting Athena and how and why they might be carried out. So one of those public sources is Twitter, and that's what we're going to focus on today. So round one, Street Fighter theme. So starting out with OSINT and focusing on Twitter. So I mentioned the word OSINT. So what is OSINT? So basically it's that public domain item from the previous slide. So all of the sources that are just publicly available that you can use to collect intel data. And this is obviously differentiated from the more closed secret squirrel type sources that are out there as well. So why use intel for Twitter? Seems kind of a bit of a strange place to start, but then again, all the cool kids are doing it. So that's obviously a big thing. There's actually a lot of really good information available on Twitter. Things like malware indicators of compromise, news on various breaches that have occurred, even things like brand sentiment. So looking at how does the community and the public in general view your brand as an organization? Obviously, if your organization's made some business decisions that haven't been so popular and people are not very happy with you, then that can increase the likelihood that you may be attacked. So it's always good to be across that sort of thing, and Twitter's good for that. Because it's short, sharp, and sweet. Twitter tends to be quite timely. Information gets out pretty quickly, and so that's definitely a benefit. And there's also a lot of native tooling support for Twitter, which makes it really easy to integrate pretty quickly. And there's a bunch of good memes on there as well, and obviously memes make the world go round. So that's another point that we should be across. All right, so starting off, and this is exactly what we did in starting off with ingesting Twitter for our intel purposes. You can use Tweetdeck. So Tweetdeck is a built-in native capability that Twitter provides. It's basically just a dashboard that lets you collect all of your Twitter stuff in one screen. So you can set things up, all of the specific accounts, search terms, hashtags, whatever you want to keep an eye on in the Twitters. And put it all on one screen so you can kind of keep an eye on it in one place. It's really easy to set up. It's free. It's pretty awesome. Some of the downsides are that you obviously have limited screen real estate. Unless you get a bigger monitor, there's only so much you can put on one screen. And obviously it's manual too. You've got to sit there and watch a dashboard in order to make sure you don't miss anything. But not a bad way to start. Does get you visibility in some of this stuff and start to use the information that's out there for your cybers. So as an example, this is actually one that came out, it was about a week ago, so last Wednesday this one came out. A tweet about a particularly aggressive phishing campaign that was started last week. Couple of domains in there, some screenshots, obviously highly actionable, right? You can go back and you can look in your web logs, you can look in your email logs, and you can understand whether this particular attack may be targeting your organization. And then you can have a look and maybe block those URLs so that no one will get tricked into clicking on it, or maybe take the screenshot and push that out to your user community so that they're aware of the phish and don't get caught. So yeah, really helpful. There's a bunch of good stuff out there, as I said. Some of the suggestions here are probably more focused at financial services, which is where Athena plays. But there's a lot of stuff out there. As I said, there's some stuff on Mac OS. So we're a bit of a startup, so we use Mac OS. So we keep an eye on Mac OS malware, bunch of phishing things. ransomware leaks, also the public sentiment stuff that I was talking about before. So we have a bunch of search terms that look about how Athena's being viewed in the public domain, and that's really helpful. And also Taylor. So obviously Tay is a very, very important source of threat intelligence. You should definitely add her to your Tweetdeck. All right, so end of round one. We have now manual notification of relevant Twitter information, which I reckon is about 10% awesome. We've obviously got those downsides that we were talking about. So not perfect, but we've got some stuff coming in, so that's a good place to start. So it's about as awesome as Dalsim's taunt there. I will meditate and then destroy you. I don't know what that means, but yeah, it worked for him. All right, so how can we do better? So I think, this really seems to be the theme of the talks today. It's really around automation and saving those precious cycles that your cyber team don't have time for. So how can we do better? How can we do better and start to automate some of this? So obviously setting things up, manual's good, but I don't want to sit there watching a screen. I need to sleep. We can't be watching this 24 hours a day. It's also, consistency matters, and definitely at Athena, we have a bunch of different cyber threat detection and alerting rules that we have out there, and they alert through a standardized alerting pipeline that gets the data to us so that we can then investigate and do things with it. So we really want these Twitter alerts to be consistent with that alert pipeline, everything coming through, the same sort of form so that we have it, in a known quantity. Also, we use Splunk Cloud at Athena, so we use the cloud hosted version of Splunk. So we really need something that's compatible with Splunk Cloud as well. So I'll preface this with, this is just one way of doing the automation. One thing I really love about the cyber community is how open and freely sharing we are, and I love the fact that we can sort of go out there and say, here's one design, and then really spar with the community on other better ways to do things, and kind of learn together on all of this stuff. So this is just our design. This is what we started off with. It's working really well for us, but there's nothing stopping us from moving into another solution in the future as we need to. So what we did is we've got Integra Map, which is a SaaS service that allows you to connect things into other things. So basically join services together. And there's a bunch of different types of these services out there. And that's hooking into Twitter, so we can get the Twitter data in. And then that publishes the results to a Splunk HTTP event collector, so the HEC. And that's in Splunk Cloud. So it's actually a pay thing. We actually pay $9 a month US for the Integra Map side, but not too bad really. I mean, I pay more for Netflix. So yeah, that's not bad for the value we get out of it. So first, before we jump into it, what the heck is HEC? So for those of you who haven't played with it, go and check it out. It is really awesome. It's so flexible. We use it for a bunch of different things, not just what we're going to talk about today. It basically is a HTTPS endpoint that allows you to post data in and then have that appear in a Splunk index, so you can do more stuff with it. It's authenticated, so there's a token that you need to provide to authenticate into that service to prove that you're allowed to post that data in, and it's also encrypted if you use HTTPS. So if you're using Splunk Cloud, this is not one of those things that you've got to put in a support case to get provisioned. This is completely self-service, so really easy. It's like a 15-second job. Click next, and you're done. There's also support for multiple connectors. So you can also set up different collectors based on different use cases and route that data into different indexes so you keep everything nice and clean and separate. So go and check it out if you haven't already. So what is Integra Map? So talked about this as well. There's a bunch of these sorts of services out there. Things like if this, then that is another one. We found that for this particular use case, Integra Map was the best fit for us, which is why we chose it. And there's a free tier which lets you do a bunch of stuff, but we found for the Twitter things that we're doing, we actually needed the basic tier, which is the $9 a month thing. So if you're a millennial, or if you have millennials in your team, you'd be okay with this because there's a nice graphical interface, no CLI. So yep, that all works. Yeah, go and check it out. All right, so I will say that I'm just going to go through a high level of how to implement this, because the idea is that if this interests you, then it should be really easy for you to go and copy paste it into your environment. I've got the full details up on GitHub, so I'll provide the link at the end of the presentation. I'll just do it at a really high level for the slide deck. All right, so you basically go in, create a new index so you can keep your data separate for your OSINT, create an input, which is just settings, data inputs, specify your source type, in this case, JSON, and then go done. That's it. It configures the input, generates a token, which you've then got for the next step of implementation. And you can actually get that token value after you've created it. So you don't have to be too concerned if you've accidentally clicked off that screen without noting down the token. From there, we pop across to Integra Map. So as I said, this is on the basic plan, which is needed to monitor a list. So what we actually did, and what I'd suggest doing is you go into your Twitter account and you create a list, which is all of the stuff that you want to monitor. So effectively all of the things that you had in your Tweetdeck from round one or round zero, whatever I called it. So you put all of that into one list, and then that's a single point that you can then integrate into Integra Map. So you add your Twitter account. It steps you through the OAuth dance to authenticate in, and then once it's connected, you just point it at that list under what they call a scenario. So scenario is basically just the automation use case within Integra Map. Once we've got that in place, that's the input to our scenario. Now we need to do the output. So the output is going to be a HTTP module. So we add a new HTTP module, and this is what we use to post the data into HEC. So Integra Map allows us to put custom headers in there so we can pop in the token value that we got from the previous step. And then we can configure the body, which just does the translation, the mapping of the Twitter data and mapping that into a JSON blob that is compatible with HEC, that gets us into Splunk. And then all we need to do is really then set that to poll every X amount of time to pull that data in. So for us, we do every 6 hours. We found that was the sweet spot between getting data in a timely way and not sort of being too aggressive in how many times we were checking. 6 hours is good, but that's what we use. Change it to meet your needs. And there you go. Data's coming into Splunk, which obviously means that we can do all the things from there. We can search on it. We can filter it. We can do all the things that Splunk allows us to do, which is super awesome. I don't know how she does that. That is pretty amazing. That's my goal for 2021. All right, so end of round two. We now have automated ingestion into Splunk, which I reckon it's still a little bit manual, right? You've still got to watch the Splunks. It's really moved that dashboard that you need to watch from TweetDeck into Splunk. But we now got a bunch of other things we can do with the data because it's in a common platform that we can work with from there. So about 60% awesome. But I reckon we can go further. So again, we've still got that manual side of things that we really want to automate all the way through. And as I said, consistency matters. We really want to use the existing pipeline that we use for all of our other alerts in the cyberspace. So maybe what we did is from here is now setting up alerting. So set up a save search. In this case, schedule it every 6 hours. That kind of lines up with the Integra Map polling. And then we can set that alert to look for whatever we care about within the Twitter. So I really like the idea of bringing in more data from Twitter than we necessarily need. So bring in all of the tweets, all the things, and then we can do a finer grain filter on the Splunk side of things, which is a lot more flexible. So in this example, we're looking at everything coming in from the ABC News Twitter account. And just looking for anything that's breaking news, so anything with the word breaking in there. You'll notice we do a URL decode on this, and that's because when we move the data across from Integra Map into HEC, we've actually got to encode some of the data so that it is in the right format. So special characters and things won't really work in that post. So we've had to do some URL encoding. So what we do here is we just do the other way around, pull that data back into a form that's a lot more readable. Yeah, so we can set up things like this and then set the alert to action into whatever you like, however you do things in your org. It can be an email action, could be Slack, could be AWS SNS. For us at Athena, our alerting pipeline is from Splunk into Opsgenie via the Opsgenie add-on for Splunk, which handles all of our who's on call, routing between different teams, depending on what the alert is, all of that side of things. And then that goes into Splunk to tell people, into Slack to tell people about the thing. And then eventually into Jira as well, which is what we use for ticketing. So it lets you do all of that consistent stuff the same way that you do all of your other alerts. And as I said, you can filter. We've got some stuff where we will filter based on only financial services related stuff, only Australian related stuff, whatever you like. You can fine tune that as you need to. All right, so that gets us through the manual side of things, and now we're automating this all the way through. Like as soon as there's a relevant tweet, all of a sudden we get a Slack message, we get a Jira ticket, we're all good. But the capability that we've got and that we're paying $9 a month for, surely there's some other stuff we can do. So bonus round, what else can we do with this awesome capability that we've just built? So the other thing we're looking at is, so we had a bit of a brainstorm internally. We're like, what else can we do? The other thing that Integra Map supports is RSS feeds. Now, it's not just Twitter and RSS. There's like thousands of different services that Integra Map supports. So there's a bunch of capability out there. But we thought about our RSS, and another problem we had was, how do we keep on top of all of the new vulnerabilities that are dropping every day? So for those of you that don't know, generally these CVE numbers, which tracks vulnerabilities, generally assigned out by NIST. And they publish these CVEs up on their National Vulnerability Database, the NVD. Now, thankfully, the NVD also has an RSS feed associated with it, that every time there's a new vuln that drops, they'll publish that to the RSS feed. So what we can do is we can set up a new scenario in Integra Map, but instead of Twitter as the source of that data, we can set it up to be RSS and point it at the NIST NVD RSS feed. Then we can basically add the same HTTP post that we were talking about in the previous example to post into a different HEC data input to pull in all of the new vulnerabilities that are dropping every day. Super helpful. But we can go even further than that. So what we've done is we've created a big lookup table of all of the tech that we use at Athena. And you could do the same. Now, wildcards are supported in this stuff, so it doesn't have to be like the exact thing. But what we can do is we can now set up our alert to only alert if there's a new vuln that drops relating to some tech that we use at Athena, whether it's Okta or Mac OS or whatever. Then we can just make sure that we only get it alerted on the things that we actually care about. So yeah, and then again, just goes through the standard alert pipeline. So everything's nice and consistent, goes through to tickets. We don't have to do any of that stuff manually. Righto, so end of round 3. We now have automated Twitter and vulnerability alerts, completely customizable, all of the history in Splunk that we can use for analytics or whatever we want, all coming through our consistent pipeline with no manual interaction from start to end, which is pretty awesome. And has been really awesome. This has been really, really helpful for us as an organization. And it's really helped us move really, really quickly and avoid spending time on things that we don't need to. As I said, there is some stuff up on GitHub. I don't know whether we can maybe share that in the chat or something, but I've included some more detailed steps on how to configure all of this on GitHub if that's something you want to go and play with. Even if you don't, I'd really encourage you to go and have a look at HEC. It's super handy, and I'm sure there's a way that you could use it within your organization. Cool. That's it.
Awesome job, Bill. I got a couple of questions from me. How did you manage to get a $9 a month business case approved? That must have been tough for you.
We're a fintech, right? We just that happened. I think that was about a 12-second conversation with the boss. So yeah.
What's that, a 0.0001 increase on a home loan somewhere?
It's not the it definitely wasn't the end of the world, that price tag.
And I'm still lost as to where Tay fits in. Street Fighter Tay fits in.
That's she's very up on all of the threat intel. So yeah, a lot of good info. Cyber info comes from Tay.
All right, good to know. If there's any questions, feel free to put them in the chat.
There are a couple. How reliable is Integra Map? Does data go missing and not ingested?
We haven't had that problem. I mean, we're not talking about huge data volumes here. So, I mean, it depends on how much of the Twitters you're pulling in. We've got about maybe 7 or 8 accounts and a few hashtags that and terms that we're keeping an eye on. So we're talking about probably we get maybe in the order of 2 or 3 tweets that come through as alerts each week. So definitely not high volumes. We're not seeing anything go missing. But we also, truth be told, we also have our Tweetdeck up as part of the, the general, whoever's on operational stuff for that particular week, they'll be keeping an eye on the Tweetdeck as well. So just as a bit of a fail safe.
Another question, maybe a bit more on the analytics space. Have you noticed any interesting trends or alerts from Twitter, in the time that this has been implemented?
I suppose there's a few different ways we could look at this. I know that we've definitely picked up. So I mean, this is all public domain. I'll still be a little bit vague in what I talk to in terms of specifics, but I know that a couple of months ago there seemed to be a big uptake in financial services targeting in Australia, particularly in kind of our space, in the home loan space, which was really, really interesting. So there was a period of about 6 weeks that, just all of the things were happening. And then all of a sudden it dropped off. So it's really helpful, especially when you can go back and run analytics through Splunk and look at, well, what was my number of alerts over time, and look at keywords within all of that. You can start to pull out some of those trends that I think you're alluding to. But there's also some stuff within Twitter itself that you can look at, like trending terms and things like that. Probably less applicable for the cybers, but there's some stuff there that we haven't actually explored yet that may be handy. We'll probably do that in the future.
Another question, have you considered looking for really actionable threat intel items like hashes within tweets and auto correlation, potentially even looking at leveraging MLTK or natural language processing?
Just thinking about that. So I guess I probably differentiate, I'd probably bucket intel into a few different areas, but I'd say for hashes and actual IOCs, I'd probably put it in a bit of a different bucket. I mean, the sweet spot for us here was really around TTPs and looking at particular actors, particular industries that were being targeted and those sorts of things. So probably that higher level intel. But we have done things like, as part of when we get those alerts come through, we will pull hashes and we'll throw them into our EDR or whatever, and block them if it's needed. But yeah, no automation on specifically hashes and actual IOCs at this stage.
Very good. What about some tuning to weed out false positives? Have you found that there have been false indicators?
Not really. Again, as I said, like we're really looking at that higher level of intel. So it's really more just, it's not stuff that we're looking at this particular hash and that's a false positive or something like that. It's more, there's been a bunch of stuff on the dark web of someone selling accounts for this, that sort of information. So it's not really the sort of space where you have the issue with false positives. But also in terms of the alerts, we don't get an awful lot. As I said, maybe 2 or 3 a week. So it's definitely manageable. And maybe that's just because we've got a carefully selected list, and the stuff that we're watching in Twitter is actually, a carefully curated list that is not too noisy.
On the costing side, you mentioned that Integra Map is what, $9 a month. Is there any cost from the Twitter API side?
They haven't charged me. I don't know if maybe there's something I should be doing that I'm not. I don't know.
Is there anybody from Twitter on this call?
I'd just like to caveat this, that anything that I've talked about today, I'm not actually doing, and none of this was real.
It was all theoretical, yeah. Perfect. Any more questions from the audience?
Yeah, it's Nick here. I'll just follow on from that one. Bill, there's a free Twitter add-on on Splunk Base. Is there any reason why you went with, a paid one, or, is there benefits of going for that paid one instead of the free one, or did you look at the free add-on? Just curious for other people following down your path.
I don't recall, but I mean, don't quote me on this, but I think it may have been we looked at it, but it wasn't compatible with Splunk Cloud, which is obviously something that we need. I think that was it.
Yeah, you're right. It looks like it isn't. So that's probably a big one.
Yeah.
Thanks.
Wondering if that was also the app that was just linked in the Q&A. Nick?
No, that's a different one.
So that's the app, and there's another one which is the add-on. But yeah, we'll put those onto the chat.
So I think the other thing too as well, right, that we saw this as just really an MVP that we were going to leverage further. So by having it in one space with Integra Map, then we're open now to doing all of the things with Integra Map that they support. And as I said, there's like thousands of services, but you know, to my point as well, like this is definitely not the only way to do it. And I'd love to see flames or other suggestions on better ways to do it. I mean, we can all learn together, right?
Perfect. One last question that seems to have come through. Is there any benefits to considering non-English tweet sources as well?
Absolutely. Absolutely. And there's really nothing stopping you from doing that. I think if you're doing URL encoding on the HEC post, then that should handle any other character sets that you're pulling in. We don't. It's probably just because I'm not very good at languages, but we do have other language support within the team. So yeah, it's good point.
So for any of the Irish participants today, they're on to us. Awesome deck, Bill. Thank you very much. Really enjoyed it.
Yeah, great work, mate. Really good presentation and great theme throughout the whole thing as well. I really liked it.
Thank you for having me. Appreciate it.
Fantastic. I know some customers that will be interested potentially in that as well. So great conversation to starter.
All right, let's move on. So thanks very much for that. Now we're going to have Yaniv Feldman, who is from our customer success team. So he's going to run us through some cool new features and tips and tricks and things like that. So take it over, Yaniv. Go ahead.
All righty. Hi, everybody. I'll share my screen. Just let me know if you can see that.
There, perfect.
Yep. All right. Great stuff. Good afternoon, everybody. My name, just I guess a quick introduction, is Yaniv Feldman. I'm a customer success manager in Sydney, and I'm looking after some of our customers in the financial services industries and the retail industry. I've been with Splunk for over 2.5 years, out of which I spent first year and a half, give or take, with a professional services organization as a consultant. And then I moved to the role of a customer success manager. Today, I'll be talking about a couple of new features around search productivity that were announced in the recent version of Splunk. But I'll also be talking, and I'll spend most of the time actually talking about some really, really exciting features that were added to the tstats command. And don't worry if you're not familiar with that, we'll go through that through the call. So I guess we'll start with search productivity. And I'm wondering if anybody in the audience have had an experience of working with searches that are quite long. And I use the, I guess, the term burden of business logic, and basically to represent a real life example from my life as a PS consultant, crafting searches with a bunch of business rules and formatting that really made the searches a bit hard to track and follow. The thing is that with the additional complexity and the volume of business rules and formatting rules that we're adding to the searches, we're not just making it hard for us to kind of track the changes or the functionality of the searches, but it's also makes it harder for other people who interact with us in a team to collaborate on a search or understand what it actually means. So with version 8.1, Splunk introduced what we call SPL commenting, and that was off the back of a lot of feedback and requests from the field on the product. Basically, it's a capability that allows you to directly add your comments into the SPL statements, and just makes it easier to read, easier to track, and navigate through the long searches, which is a very important need. Essentially, it's quite easy to add. It's just a matter of adding 3 backticks on top of our SPL, and we'll add our comments wherever, like we see here on the screenshot. The good thing is that it supports multi-line, as you can see here in the second line. And basically everything that comes after those 3 ticks is completely ignored in the SPL command, so it doesn't get evaluated. So this is something that I think would provide a lot of value. And moving into the next feature, that's pretty cool. There's also a nice addition which allows us to access our search history directly from the search bar. And it's quite easy in the sense that it allows us to just pick historical searches that we've done in the past, and becomes quite handy when we want to just dig up old searches that we previously run and need to run them again. So instead of looking them up, copying and pasting them, we're just able to run them directly from the UI straight into the search bar. So that's quite nice. But the reason that I was wanting to spend most of the time today and in the presentation is to talk about T-stats. Now, for those of you who are not too familiar with T-stats, just give a quick background. So I'm not sure, I mean, probably got a chance that you ever had to write a statistical analysis or do a statistical analysis over a large data set or a large time period. So how would you traditionally be doing that? So for example, in the cases we see on the screen, we'd just like to count the events on our UI access on the Splunk internal index. We'll craft the search that fetches and filters the events. We'll specify the index, the source type, and then we'll just do a time chart and count. So basically helping us to get a trend of the events that correspond with our filters. How does it work basically? Once we've sent our command or our search through the UI, in the back, or sorry, behind the scenes, what Splunk will do is basically identify any buckets or any data that's being indexed that could contain the events that I'm looking to count. It would then locate those events that match the search criteria that I added using the TSIDX files. And for those of you in the audience who are not familiar with this, these are basically our Splunk or secret sauce, right? So these are the index files that help Splunk map the entire data set that's being ingested into it and being able to apply a schema on the fly and search. So once the events have been identified, they'll be retrieved. And then Splunk will apply the statistical command that I've added. So there's 4 steps here. Basically, identify the buckets that the events are existing, then map the events within those buckets, retrieve the events into our search, and then apply the statistical command. And that's all good. The thing is that step number 3, which is retrieving the events, is something that takes quite a lot. And the reason being is that that's where Splunk applies the aliases, the field extractions, automatic lookup, as well as other functionalities, which really what makes this search versatile. But it also means that it takes Splunk longer and it requires more system resources to run the search. But if we think about it, we don't really need that if all we're looking to do is just count the number of events or just a high-level statistical calculation. So can we somehow save that? Can we actually do something a bit more efficient and just go straight away into the statistical calculation without applying or without really fetching all of those events? And that's where T-stats come in. Basically, T-stats is a generating SPL command that allows Splunk to access the time series index. So that's our secret sauce, and allow Splunk directly query the index files without really searching the raw data or the raw events and retrieving that raw data or those raw events back into the search results. So the way it works is basically we just use the single command here. So we just write a T-stats command. We then specify the statistical functions, so count, sum, average. We specify the where. So this is how we'll filter the data, and group by. In this case, it's by time. So that's quite nice, and it takes off quite a lot of the time that Splunk takes to run this command. And essentially what it does is just eliminate step number 3 in the search. So that's all good. So we know we can use T-stats to run those statistical queries, but there's a caveat. We can only use the T-stats command on indexed fields in the TSIDX file. And by default, those index fields are host, source, source type, and time. And that's all good as well. But what happens if my events look a bit more than that, to contain information that I need to run my statistical calculations or queries based on fields that are not indexed? For example, we have an event here that has the fields user and action, info, duration, etc. So what if I still need to run my statistical calculations based on that kind of source data? And I would like to filter my data on these fields. Do I still go back to the traditional search and basically go back to, that search that takes a lot of time? And obviously the exciting stuff is that with version 8, we don't really need to go through that traditional search and search the raw data. With version 8, we'd actually introduced new features into the tstats command. These are new directives called prefix and term, and they allow tstats to access the index files using key value segments from the raw data. Now, since we're not we don't have too much time to cover and do a very technical talk, basically, I'll try to keep it short and say that it allows Splunk to use the index files to fetch information as if it would have accessed the raw data without really accessing the raw data. So the way it works is that it allows us to specify raw segments in our indexed events. We can use those segments to either split our events or extract fields or extract field value pairs out of our events or just filter them. So if you go back to the traditional search, we'll run index equals demo, user equals Y Feldman, action equals to search, and then pipe time chart off the back of it. Well, if we have version 8 onwards, we can actually use tstats to do the same thing. And that will shave quite a lot of the runtime. I'll show a few examples. So with tstats, we just use the tstats command, count, or index equals demo, and then we'll use the term directive to define those key value segments in our data. And that command will just go to the index files. It will not access the raw events. It will not fetch any raw events, but we still have the capability of running those statistical functions off of, which is almost similar to accessing the raw events. So how does it basically go? Same thing, same flow. So I'll run my tstats. Splunk will identify the buckets. It will the search criteria, this time using the term directive. It won't go into the raw data, but then it will just straight away fetch the results and apply the statistical calculation. And now I just want to show you a quick demo of that happening in real life. So if I'll just paste my search. So this would be my traditional search that I would use in the pre-version 8 days to basically find all of the events where user equals to Y Feldman, that's myself, and action equal to search, and do a time chart of count. Quite simple. So we'll let Splunk run, and it's on a time range of about 24 hours. So there's quite a lot of events. And we can see Splunk kind of just chugging along and searches for that information. And that's all good. We'll let it run. And in the meantime, we'll open a new tab. There we go. So Splunk has finished the run. If we go to job and inspect job, just to see how long it took, about 28 seconds, or almost 29 really. So that's good. Let's see if we can, well, actually stay here the same way. Let's see if I'll just paste my tstats now. So tstats count where index equals demo, and then I'll just add the term directive, and I'll specify user equals Y Feldman. And then the term action equals to search. I'll do it by time. I'll run the search. There you go, done. Same results. I'll go to inspect job. Took less than a second to run. So we can really see how it helps our experience as operators or users of the platform to just get faster results on much bigger searches. But more so, it really takes off a lot of the search or the workload from Splunk. So we can do the same, we can achieve the same functionality with just the system really using much less of the resources that it has. So if I'll go back to the presentation to do a summary of that capability, we're looking at shaving about 98% of the runtime if we go to that example. And really, the search isn't that different. So, but just by changing the stats command, or sorry, the traditional search into tstats, we've achieved quite a lot. But wait, there's more. So we've seen how Splunk can filter results with tstats. So that's great using the term command, but we can also use the prefix command to group our results. And how do we do that? So basically, if traditionally we'd want to run a search that takes basically similar thing, searches for all of the actions, but now we want to do a count by action. So we just want to group our results by the field that's called action. Well, with prefix, we can do pretty much the same thing using tstats. So what we'll do is that we'll run our tstats, we'll run the same count, we'll specify the index name, and this time with the by clause, we'll just use the directive prefix and action equals to blah. And what prefix or what tstats will do is basically take or return the value that's against action. So any value that comes back from the key value pairs in the index files will be returned. In this case, I've also piped a rename. So the result of the group by basically would return a field that's called action equals. So what we'll do is that we'll name it as action, and then we'll run our time chart. By the way, we don't have to necessarily do that. We can just straight away do a tstats, and I'll just show you how it looks like. So let's go back to the demo again. All right, so I'll just paste the traditional search. Let's hit it. I suspect it will take quite a while to run, but we can see it's starting to format the results, return the results. And since we're not very long on time, I'll just stop the search here because otherwise it will take quite a lot. But now check this out. If I'll just apply tstats and I'll do a count where index equals demo, and then group by prefix action equals to something. Let's run it. That's it. Done. So what I've now got is a field called action that returns the values of all the possible key value pairs, obviously per time, and the result, which is the count. So that's good. It's not perfectly formatted according to what I need as a time chart. So what I'll do is that I'll pipe those additional lines. So just rename action equals to action, and then I'll just apply the time chart command. Done. So this way, I've been able to shave quite a lot of time. So if I go back to the slides and I have some pre-calculated figures for the same search, we're able to take down a search that took 223 seconds to 5 seconds. So obviously, significant reduction in the runtime. So I think it starts to tell the story here. And I guess we'll just go through a couple of additional capabilities. So far we've used tstats and the new directives to filter the results, and we've also used to do a group by. But what if we want to extract a value out of our key value segments, and now we want to use it as a statistic? meaning I would like to calculate the average duration, and duration is a field in my events. So traditionally, I would just run this search as we see here. But really with tstats, we can just use the prefix directive to extract the values of the any key value pairs of the field duration, and then aggregate them. So quite the same usage, but we just apply the prefix directive within the aggregation function rather than after the by clause. So pretty straightforward. Let's do a quick demo. So if I run my traditional search, don't need earliest, just stick with index equals demo, average duration. Let's see how it takes. Actually remove the span. So Splunk will search and search. Choose OK. Will take a little while, and now it's complete. So it took about 13 seconds. In real life, we'd probably expect this to be a bigger number. Let's apply the same thing. So tstats average, and this time using the prefix within the aggregation function, so within average. Run the same search. Done. Easy. So again, significant time reduction. Now moving forward, and I think everybody starts to kind of get the idea. We can now use prefix not just in one place. We can actually put it in a few places within our search. So we can use prefix to extract a value and get it as and use it as a statistic. And we can also use prefix to group by the results. In this case, we'll search for index equals demo, action equals star, and then average duration and group by action. But with tstats, we'll use average and extract the key value pairs from duration using prefix. And we'll then group by the results using prefix. And basically same idea. So a search that would traditionally take, in this example, 16 seconds, we'll reduce it to maybe 1 second. So quite handy. So if we try to summarize the capability, essentially tstats is really, really good for statistical calculation based on index fields. But with version 8 onwards, tstats is not limited anymore to the indexed fields, right? We can do the same calculations, and then we can access the key value segments from the raw data to do these calculations. We can do this using the term directive and using the prefix directive. We can do filtering, we can do group by, we can do extract of values, and we can combine them together using tstats. And obviously the benefits will be significant reduction in our search runtime. So everywhere we saw with like plus 95% of the reduction. But I think even more importantly, this will drive significant resource consumption down of our search. And that's a good benefit, for our platform as a whole. And lastly, now I just want everybody in the audience to think about your most complex dashboards that could potentially have a lot of, dozens of panels, a lot of searches, either base searches or panel searches. Try to think about the alerts that you have in your system and the searches that you have in them. And now what I'd like to do is to challenge you to think on how you can rebuild or use tstats with the new directives that I've just shown to basically to implement in those dashboards and imagine the impact that would have on the user experience and on the platform. So I'll give you that challenge, and hopefully maybe in the next user group we'll hear some of the results of that. That's pretty much it for me.
Thanks for that. Yeah, that was good. Lots of performance enhancements there. We've got a couple of questions in the Q&A, and I'll just ask you those. And anyone else on the panel might be able to answer them as well if you don't know the answer. So first one was from Gareth. Was the history feature with shortcut keys on premise as well as just cloud? So that early feature that you talked about, I'm pretty sure it was released in 8.1 for on premise as well, but yeah, I can
That's
see
right.
So we confirmed that. What else have we got here? So why not make the traditional, so with the tstats commands and the performance improvements, why not make the traditional search do what tstats is doing rather than having to use a different command? So I guess that's just more of a product management type question. Why not making it simpler? I've got my thoughts on it. Have you got any thoughts?
Basically, the traditional raw event search is more versatile. It's meant to give the user basically the capability to get visibility to an event and do whatever they want with the event. But you know, as you said, it's probably product management, so you can choose either or. It's essentially a matter of what the kind of, I guess, functionality you want to bring to the broader Splunk user.
Yeah, and the other thing with that is I think when we have discrepancies of which ones can be used, as Gareth mentioned, that's when the search optimizer will start to come into play and hopefully choose the best option for you without users needing to do it themselves. Okay, what else? Can you use wildcards in the term value field, e.g. term brackets field equals value asterisk? So yeah, can you use wildcards? Have you done that before?
I believe you can, yes. But if you can't, all you need to do really, and if maybe I'll share my screen, is, and maybe I'm sorry if we're taking too much time. Can you see the screen?
We can, yep.
So so you can either do something like action and fetch all of the field value results. You can rename your action as field and then search equals wildcard, whatever criteria. So this is how I probably approach it.
Yep, no worries. Hopefully that answers the question. And then the last question we have is, again, a bit of a product management question. Should we expect support for old Splunk versions to drop off from Splunk base quickly as they're updated to use new tstats functionality? So I guess alluding to the fact that with new apps, as they start to support this new functionality, they're not going to be able to support older versions of Splunk because you'll need the new commands. Yeah, so any thoughts on that? Anyone on the panel?
I guess it's a matter of designing, or I guess designing for backwards compatibility when you release a new app to Splunk base. Personally, I actually happened to release an app in Splunk base a couple of months ago. This was actually a consideration. So what I tried to do is craft, and I wanted that app to be backwards compatible. So I crafted traditional searches. However, I did use summary indexes to make the search or the results as I guess small or the resulting data set as small as possible.
Yeah, that's right. And look, I think it would be great if everyone started using these new features and improving the performance. So it'd be a good problem to have, to be honest, especially on the side.
I also think the deprecated features, there's quite a runtime before they're actually deprecated, right? Like we do support them for a number of years. So kind of wanting to keep up is a good thing to do for any of our customers and partners here. Holding on to old versions doesn't really help anybody. Like there's such great efficiencies and advantages of staying current or -1, -2, but not really much further.
Yeah, perfect. Thanks very much, guys. Really appreciate that presentation, Yaniv. And I think a lot of us have spent a lot of time trying to troubleshoot why dashboards are slow and things like that. So I can imagine that's going to be very helpful for a lot of people in this call. All right, we've only got 5 minutes left, so I'll just very quickly run through a couple of small things. All right, so I just wanted to very quick recap on .conf. Hopefully a lot of people were able to attend .conf live when it was on a couple of months ago. But if not, I just wanted to share a couple of links with you. So it was our biggest .conf ever. Over 30,000 attendees, 200 plus sessions, over 50 hours of global education. There were 7 guest speakers, as in not Splunk or customers or employees. One Gwen Stefani, which was a cool concert to watch. And being virtual, $0 lost in Vegas, which is always a win right there. But if you did miss it, for the time poor, which we are right now, there is a 6-minute keynote highlights video that's been released. So if you missed the presentations, you don't want to watch 3 hours worth of keynotes, there is a 6-minute version of it here. So we can share that link after this call. Yeah, it's on the Splunk website as well. So feel free to jump in and watch that. It does cover the key things that were talked about, but not everything, obviously. And lastly, there is a pack that's been, or a page that's been put together for the top .conf 20 sessions. So this is just a summarized view of the most popular sessions that were at .conf. This actually isn't on the Splunk website yet, but if anyone wants a copy of it, you can reach out to your SE and they can send it to you. Also try and send this out as well as after the session if I can get access to everyone's emails. And that's it. Thank you very much for your time, everyone. It was a really cool session. A lot of great presentations. Thanks to our guest speakers, Bill and Andy. Did a great job presenting there today. And I hope everyone just has a great holiday period, keeps out of trouble, and enjoys the time off.
Thanks, Ash. Thanks to all our speakers.
Thank you.
Thanks to everybody for joining us today.
Cool.